Mr. C Sharma. He is the Chief Business Development and Technical Service at Tata Power-DDL. He has been associated with Tata Power for the last 18 years in different roles, and presently he heads the function that includes business development, power system control, quality assurance, and technical service. Today, Mr. Sharma will talk about underground substation and digital grid substations.
I feel that whatever digital substation or digital things which are coming in to utilities or to the electrical power system, the backbone behind that or the development behind that is more to do with the communication. The technology upgradation with time, which has gone from 3G services where the communication rate was in KBs and then we moved in MBs, and now we are looking to 5G where we can have a communication rate of in GBs, 10 GB per second. So that is probably the backbone or the carrying backbone of entire development in digital world and power system. And going further, 5G is right now almost at the verge of implementation. The preparations are going on. There are interactions from our end also with some of the communication utilities, and they are working probably in a very short time. This would be launched, and looking further, it may be a satellite communication which may ease out the things further. So it is the communication from the field which is going at a very fast rate to our substations, and the processing afterwards that's making all these things happening. Coming to digital substations, at Tata Power, we have around 80 substations at 66 kV and 33 kV levels, and all these substations are unmanned, not a single person. Before we took over from erstwhile Delhi Vidyut Board, these substations were manned by almost 8 people, and then 3 shifts and all those things, putting together some 800 to 1,000 people were deployed in all these substations. Today, our substations are all unmanned substations. Even not a single person is deputed there. Even the guards which are there on these substations, they are also shared among the substations. Like one guard would be guarding 3-4 substations, and we have an integrated security system also, which is keeping an eye again due to communication or very fast communication, processing of the data, putting the data on the back end, so that an immediate action can be taken from back end also. That is the as of today's story. As far as digital, where we have removed all the control cables and we are totally digital. We have around 3 substations, and we have few more in making. We would be sharing with you the experience which we had while implementing and maintaining all these substations after installation, during installations, and then economics part of it. We start with like CTPT in the field. If we see here, we have these field devices, mainly CT, VT and all those things, and then they are getting merged in merging units, and then we have the process bus here, and from process bus we have the protect relays and the communication BCPU, which we call it, which has a communication as well as protect, and then we have the further bus and then the central control. As far as one of the things which is important here again comes with the cyber security with recent disturbance in Mumbai power system. So of course it is otherwise also basically prone to cyber security attacks and all, but we have to be very, very careful while implementing all these systems. And the data which is getting collected on the back end in our grid control room, it is for all the substations put together, and the processing of the data, and then the action point where there is a disruption which has happened, or where the discontinuity of the supply. So the immediate action of sending crews or taking action, or like switching on and off and changing the supply position, that is like on almost real-time basis is taken based on this data from the field. Advantage, if I talk about a very low energy fiber optic signals, all is running very fast, no wires and cables, so the maintenance cost is very less, and then definitely it is a very climate friendly installations. Compact is like little compact, almost 10% space is saved while we adopt this type of substations. Reliability and availability, of course, is increased, and the look wise and feel wise, it looks very good because of not a bundle of cables which are going into the control room. Only some OFCs are going inside, so that makes the system very as far as look and feel is concerned. Then going further, of course, we are in a process of installations that instead of bulky CTBT units, if we can have the sensors, where the sensors can sense this current and voltage, and the current and voltage can be taken to the control room. So that can be one of the future thing which we can look for in times to come. And thermal imaging cameras are already there, where we can have some cameras and which we can monitor the hotspot formation, loose connection, and all those things through these cameras. And the security cameras, as I have already told in the beginning itself, that these security cameras are very intelligent cameras, and then they can detect. In fact, we could analyze some of the events which were happening, like failure of equipment, in a greater detail rather than we being there. We could have not analyzed better than this when we saw in the camera. So that's again a very plus point of fast communication and the distance substation. Challenges, if I come to the challenges which we have felt during last almost first installation for digital bay. In fact, we started with the first bay. We started around 5 years back, and we found that there are merging units which is being used in the field, and these merging units are basically getting heated up, and basically they are giving problems when these are being installed in Indian conditions. So Indian conditions, rather it is very harsh and highly polluted environment. So these units, many times the failure, heating up, all those things are happening. So that needs to be seen, that whether this can be Indianized, whether we can make it in India, so that the local factors can be taken care of. Cost right now, I do not know. In fact, this is running for almost 4 or 5 years from last 4 or 5 years, but still the costs are very high, and the cost has to come for the maintenance, initial buying, as well as for the maintenance also. So we need to look into these two. Coming to sensors are there. A lot of array of sensors is there in the market, starting from Omron, and all those people are providing the sensors. But we need to see that these sensors are standardized and they keep on communicating. Their life cycle is to be seen, whether once we install a sensor, how many years life it can give it to us, especially the regulated environment of the utilities, of the power. And also what has happened is that we have seen that many relays get failed in Indian environment when we put our relays in this polluted environment. They say that there is a sulfur deposition on the relay circuits, which basically causes the failure of the relay. So whether the sensors which we are putting right now as of today, whether they will be able to live the expected life of 10 years or 15 years in times to come. So that needs to be seen and tested, at least in lab environment, that these are basically live up to the expectations of the users. So this is for the digital substations, and we have a GIS system in DPDDL. ISS, already I have talked about it. This is integrated security system. We have all the cameras and installed. We have thermal cameras, we have normal cameras, we have intelligent cameras, we have the system like perimeter control and all those things, which is like effectively as of today doing the effective surveillance, and we have not faced the major problem in our some 80 grids as of today. Now GIS has been our backbone for all the systems which are running, but in GIS, apart from installation and the initial installation, the major challenges which are coming or which comes for a utility is basically the updation of that GIS. And updation means accurate updation with respect to the real field conditions, because geo-references in the field, they keep on changing. Like the road has been made today, tomorrow there may be a flyover, and the day after the road may be widened off. So it's not like with respect to something. We need to have something where we can connect it to independent of the Earth system. So what we thought of GPS starting with, but GPS, with the normal GPS what we have in our mobile, the accuracy is 15 to 20 meters. But for electrical system where we install our substations, our cables and all those things, we cannot have a system which can tell, okay, the cable is at this point or 15 meters here and there. So we have to have a very accurate system, and this real-time kinetic system which we have installed, where we have installed another small satellite in our area. It works like this, that this is having accuracy of 1 centimeter. In fact, they call it sub-centimeter accuracy, but in spite of all those things, we are getting a very good accuracy, and it can give you, like, this is the place where we have installed the system. So this is also very, very important from maintenance point of view. And while any asset is put into the ground or above the ground, what we are doing is that we are mapping basically the GPS coordinate with the system. And while we have to maintain it, or we have to dig out the cable in case of failure or anything, then we relocate that particular thing with the same system. And the accuracy, as I have already told, it is up to sub-centimeter. It is less than a centimeter. So that is the beauty of this system. Going further, see, in metros, we are always facing an issue that there is no space, especially for the electrical system, utility, even meter. In our house, when we put a meter, we find a very, very bad place where nobody goes, and which is a very dirty type of place, maybe below the staircase or anything where nobody goes. That is the space given to the meter, which is a very sensitive device. But once it comes to utilities assets, nobody is ready to give any space at all. And especially in environment of metros, it is very, very difficult to find a space. Even in Delhi, we always hear that even for a parking, there is a good fight. So what the electrical assets are to be installed permanently there. So almost there is no space. So what is to be done? So what we have done is that we have installed an underground substation. This is a substation. This is a normal substation which is done above ground, and it takes a space of around 25 to 30 meters square, depending upon the size of transformer. It takes that much space, and it is above. If it is above ground, you can see that how much space it is occupied. So then challenge was that how we can make it zero space occupying substation. So what we have done is that we have designed a substation where the equipment can be put inside the ground. So these substations are basically being done in West, but these are very, very costly with respect to the Indian condition. A normal substation, which you are seeing conventional on the left side of it, it takes around say 15 to 16 lakhs to install, whereas this underground substation, which is put in a West, both RMU and transformers, the cost is around 1.25 CR, 125. So huge cost. So what is to be done? So in that case, we have collaborated with one of the BAs. We were there. We were just trying. We were in discussion with many people, but finally we succeeded last year, and we got a transformer developed in India itself. And this transformer has a capability that this transformer can be put inside the vault. It is a concrete vault all around, and though the water cannot come from this concrete vault has been made in such a way that water will not come inside. But even if water comes, this equipment is capable of getting submerged into the water and then also run. So that interruption is not seen by the equipment or by the consumers in case of water logging inside the vault. So this type of substation, probably these underground substations or some with submersible transformers are not made in India very frequently. We are not aware whether any such substation is existing. But this is a very good substation. Maybe it can be considered to be a regular phenomena in all metros where you have a very scarce space. So and then you at the same time you can have a liability of the power, that the power will not get disturbed due to storm and water. So this is again another view where the car can be parked and this space can be utilized. Even in front of mall, this type of substation can be installed and the people can walk over it and the substation keep on running inside. These are some of the advantages, that it is very safer, no animal electrocution, the surface can be used, eco-friendly, and there is no effect of flood or water or whatever. This is another substation, again underground substation, that was outside, outdoor type of substation. This is an indoor type of substation. Only one small topic I will take further, that is LV automation. Basically, we always talk about the automation at transmission level, at the 11 kV level, 66 kV level, but LV automation is the phenomena which has to take up, because a lot of automation has come at higher voltages, but low voltage at which we as a consumer are being served, there is still a lot to be done, even everywhere across the globe it is to be done. The LV automation is not seen much across the globe, not only in India. So this is one thing which is basically we can look for going further, that how we can promote the LV automation, where we can have the self-healing network, with the consumer supply can automatically healed and automatically connected, and we get the signals from the field at the very level of consumer, that what is the status of their supply, and automatically the field crew can be dispatched there. I'll take a very small time because I know that I have already taken 20 minutes. I will skip some of the slides. This is the LV automation thing. Around 200 substations we have completed, where we are taking temperature for the transformers. We are taking the current of the transformers. We see the overloading or the current unbalance, or even we have the plan to close it, like in the summer, if we are closing the equipment, switching on the equipment or switching off the equipment, and the fault occurs at that time, there are many times the safety hazards for the persons working on it. So what we can do is basically we can think of like closing automatically from a distance or from the central control room. So this is the area which we are taking up right now, and already a good number has been installed. We are learning out of it that what are the problems which are coming. Of course, because these all equipment which has been designed and put here, they come from the West, and West is not having that temperature which we are facing in India. So my the further learning out of all this, whether digital substation is there or LV automation is there, that we as India has to develop the things, and we as India has to develop for India. So that is the probably I'll take the last thing to mention here, that if we make equipment by Indian and for Indian, of course it will take time, but definitely if we do that, we will be more successful in the future. And with that, I complete my presentation. Thank you all for listening me.